Hello everyone, welcome to Pathan Chemistry YouTube channel. If you have not yet subscribed my channel, so subscribe it. Today we'll discuss topic solid state. In that we'll study the difference between crystalline substance and amorphous substance. We know solids are characterized by several different properties like incompressibility, rigidity, their mechanical strength, and particles of solid are closely packed. So we know gas molecules, they are in random motion, continuous random motion, they are not packed. Liquids have some attractive forces, therefore they are little packed, but molecules can wander around each other. So liquids don't have any shape, but they have definite volume. But in case of solids, they are closely packed and they are held together by different cohesive forces. We know there are two types of forces, cohesive force and adhesive force. Now cohesive force is a force between same type of particle, force of attraction between same type of particles, and adhesive force is a force of attraction between different types of particles. So therefore solid particles, they cannot move at random motion, and solids have well ordered molecular, atomic or ionic arrangement. Okay, then there are two types of solids. The first one is crystalline solid and another is amorphous solid. Okay, now crystalline, in that crystal means frost or icy. Amorphous is made up of two parts, morphe and a. Morphe means a form, shape. A means it's lacking or without. So amorph means without shape. So amorphous solids, they don't have any shape. So let us go for the next, that is definition of crystalline substances. A substance whose constituent particles are arranged in an orderly manner in a definite geometrical form is called as a crystalline substance. Then crystalline substances have regular arrangement of particles which extend over large distance in three-dimensional network of crystal. That means they are having long range order of their arrangement. And crystalline substances have characteristic geometrical shape. Examples of crystalline substances are sodium chloride, potassium chloride, sodium nitrate, then sulfur, diamond, phosphorus, and sucrose, urea, the copper wire, quartz, and there are two types of quartz, alpha quartz and beta quartz, sugar, mica, snowflakes, rock, calcium chloride, silicon oxide, alum. All these are the crystalline substances. Now let us go for the second point, that is amorphous substance. A substance whose constituents are not arranged in an orderly manner is called as an amorphous substance. These substances do not possess properties like incompressibility and rigidity to a certain extent, and they do not have definite geometrical forms, or if they have some little arrangement, that arrangement is of the order of angstrom units. That is, they have very short range order. Therefore these substances are called as a amorphous substances. Examples of amorphous substances like glass, rubber, wood, plastic, metallic glass. Metallic glass is made from glass and metallic ions, metallic salts. Polymers, PVC means polyvinyl chloride, gel, fused silica, chalk, pitch, tar, thin layer lubricants, Teflon, then fiberglass, cellophane, etc. are the examples of amorphous substances. Okay, now let us go for the next point, that is difference between crystalline substance and amorphous substance. So here one side we have crystalline substance, another side we have amorphous substance. The first point of difference is obviously, number one, crystalline solids are having a regular arrangement of particles in a typical geometrical forms. For example, here I have shown a two-dimensional arrangement of AA type of molecules and two-dimensional arrangement of AB type of molecules. Okay, and amorphous substances, they don't have any typical geometrical arrangement. Amorphous solids have a complete random particle arrangement. You can see here I have tried to show some random arrangement of the molecules or particles. The second point of difference is melting point of crystalline substances are very sharp. That benzoic acid, it melts exactly at 122.3 degree centigrade. The naphthalene melts at 80.26 degree centigrade, and many more crystalline substances melt at sharp melting point. We know in case of quality 2 organic analysis, we find out melting point of different organic molecules, and melting point is one of the characteristics to find out or detect which organic compound is present in the given sample. On the other hand, amorphous substances don't have sharp melting points. They melt gradually over a range of temperature. Like glass, if you heat glass around 1500 to 1600 degrees centigrade, it initially softens and then flows slowly. In the same manner, plastic, the glue of glue gun, the rubber melts over the range of temperature, and so melting point of crystalline substances are sharp, and that of amorphous substances, they don't have sharp melting point. Let us go for the third point of difference, that is cooling curve of a crystalline substance is discontinuous with two breaks which correspond to the beginning and end of the process of crystallization. That means if you take, say for example, benzoic acid and heat it to melt, when you start cooling it and plot a graph against temperature and time, you will find that initially the temperature decreases, the phase of benzoic acid remains as a liquid, but at its melting point, suddenly all of the benzoic acid is converted to the solid phase and temperature remains constant. After all benzoic acid is solidified, then temperature further decreases with time. But in case of amorphous substances, the cooling curve is smooth. For example, here there is no sharp change. The gradual change in temperature takes place, and this it solidifies slowly from liquid, then it becomes soft material, it converts to the solid state. Then next point, crystalline substances are anisotropic in nature, and their physical properties are different in different directions. But in case of amorphous substances, they are isotopic in nature. Their thermal conductivity, their mechanical strength and refractive index are same all over the direction. You can change any direction, the property will not change, the value of property remains same. So they are isotopic in nature, but crystalline substances are anisotropic in nature. For example, in silver iodide have a coefficient of thermal expansion is positive in one direction and negative in another direction. The velocity of light is different in different directions. For example, here the passage of light from direction A to B and C to D, it shows double refraction phenomena. Thus, the phenomena of anisotropy offers a strong evidence for the presence of ordered molecular arrangement in case of a crystalline solid. Next point of difference is crystalline solids have definite crystalline shapes and which can be easily recognized. There are solids which are microcrystalline also, and obviously amorphous substances occur as a powder form. They are available as agglomerates of fine particles, but they are not having any crystalline shape. Then crystalline substances are bound by plane phase and have definite angle, but amorphous substances don't have any phase, they don't have any interfacial angle. So these are some of the point of differences between crystalline substances and amorphous substances. So thank you for watching Pathan Sir Chemistry YouTube channel. If you have not yet subscribed my channel, subscribe it, and if you like this video, like and share and comment. If you have any problem in a solid state unit, I will try to resolve it. Okay, so thanks for watching, thanks for your time. So we'll stop here. Bye.